Hi, I'm Chloe Idris. I'm the Energy Efficiency and Carbon Coordinator at Icon Water. At Icon Water, we have a net zero by 2045 target with interim targets along the way, which align with the ACT's climate change strategy. Our emission possible plan is how we are going to meet those net zero targets. As part of that, we really need to understand more about our nitrous oxide emissions. So these fugitive emissions are emitted during the biological treatment of human waste, and it is a global problem. It's not particularly well understood. There have been measurement programs around the world, and we're one of the places with the longest measurement systems in place. Here at Icon Water, we're monitoring to try and better understand what our emissions are and how they're caused and find ways to mitigate them. There are currently no known ways that will eliminate nitrous oxide emissions, apart from some experimental wastewater treatment approaches which are not currently available. We've got an emission possible plan pathway of progressive interval targets, and these interval targets are consistent with the ACT's climate change strategy. So our nitrous oxide emissions are 70 to 75% of our carbon footprint. Because the ACT electricity grid is considered 100% renewable. So now we've got this emission remaining that is quite difficult to deal with. We're collaborating with peer utilities, the University of Queensland Water RA to compare and share data and find out more about exactly how the nitrous oxide emissions are being developed, what might we do to mitigate it, what are the influencing factors, and hopefully also to change the legislation on how we report the emissions so that can be more accurate. So this is the instrument cabinet. There are 4 hoods. Each hood has 2 sample lines that are coming to the cabinet, and for 15 minutes each hour, the sampling is coming from one hood. So 15 minutes on hood 1, 15 minutes hood 2, 3, then 4 over the hour. And we take that data, the instruments in here measure how much, what the concentration of nitrous oxide and methane are, and we use that information to develop an understanding of how much of each of those gases has been emitted over time and compare that to operational data.